Good morning. This is the math department at Amjad High School, grade 11. Today we start a new chapter on antiderivatives. The objectives of this session, this is the first session on antiderivatives. First, we will talk about the definition of antiderivatives. Then we will talk about the basic rules of antiderivatives. Let's start with an activity. Knowing the expression of the function f, find the expression of its derivative f prime. So complete the following table. In this table, you are given the function f of x. You're simply asked to find an expression for the derivative. So if f of x is x squared, then f prime is 2x. If f of x is 5x to the 10, as you know, you drop this 10, you will get 50. You subtract 1 from the exponent, and you'll get 50x to the 9. Proceeding to the next, x to the 0.5 plus 5x plus 2, so that's 0.5x to the minus 0.5 plus 5, which is the derivative of 5x2, has its derivative 0. Now, sine 2x plus cosine x. This is sine u, as you have studied in the previous chapter. Sine u is u prime cosine u, and the derivative of cosine x is minus sine x. Now, in this activity, you are asked to think backward. In the following table, you are given the expression of the derivative function f prime. You are trying to find an expression for the function. So you're working backward here. Complete the following table. So in this table, you are given the derivative, and you are asked to think of a function whose derivative is given. So if the derivative is f prime of x is a 3, what could the function be? A possible answer is a 3x. I'm saying a possible answer because what if the function is 3x plus 10? It's also correct. Actually, you don't have one correct answer here. If the function is 2x, a possible function whose derivative is 2x is x squared plus 5. Some students may ask, we cannot find this function. We couldn't find it. It's okay for now. We're just trying to find it by trial and error. Later on in this chapter, we are going to study systematically how we find such functions. But here, actually, we are giving you easy functions, and you can find the original function by thinking backward. So if the function is a 3x squared minus 1, who can think backwards and give me a function whose derivative is a 3x squared minus 1? I can expect that some students can answer correctly. And one of the possible answers is x cubed minus x minus 11. What about the minus 11 here? It could be minus 10. It could be minus radical 2. Actually, any constant here, it works. The main terms are x cubed minus x. You can write nothing here, but minus 11 plus 10 all work because the derivative of any constant will be 0. What about this one? So x to the 5 minus 2x squared plus 2x minus or plus any constant, it works. So don't worry about this constant here. Any student can give another value and it works. So what is an antiderivative? Let f be a continuous function defined on an interval I. Capital G is said to be an antiderivative or primitive of lowercase f on the interval I if and only if G is differentiable and the derivative of G is f. So a function whose derivative is small f of x is said to be an antiderivative of small f of x. Consequently, f is an antiderivative of f prime because f prime is the derivative of f. It's similar when you say that this is the father of that, then this will be the son of that if you're talking conversely. Example 1. Show that the function capital G of x sine x plus a 3x plus 2 is an antiderivative of the function f of x equals cosine x plus 3. Again, capital G is an antiderivative of small f if and only if the derivative of capital G is small f. So it's enough to derive G prime sine x is cosine x, 3x is a 3, 2 is 0. Since the derivative of G is cosine x plus 3, which is f of x, then small f of x is the derivative of capital G of x, and conversely, G of x is the primitive or antiderivative of small f of x. Again, show that the function h of x, x squared minus x minus 1 over x plus 5, is an antiderivative. This is n, by the way, is an antiderivative of the function small f of x equals 2x minus 1 plus 1 over x squared. To do this, it's enough to derive h of x. If you get small f of x, then you are done. We have h prime of x. The derivative of x squared is 2x. The derivative of x is 1. The derivative of 1 over x, this is one of the standard functions. Its derivative is minus 1 over x squared. And the derivative of 5 is 0. Simplifying, you will get 2x minus 1 plus 1 over x squared, which is small f of x. So small f of x is the derivative of h of x. So h of x is the antiderivative of f of x. Application. Match the given function f defined on an interval I with its antiderivative g. So each of these functions on the right, each one of them is an antiderivative of one of the functions on the left. In other words, the functions on the left are the derivatives of the functions which are on the right, but you need to match each one with its appropriate function. The best way here is to start with the antiderivative and to find its derivative, because it's easier for the student to derive and not to think backward. So consider this capital G of x, derive it, it will be its cosine u here, which is minus u prime sine u, and you have a minus, so you will get 2 sine x. So this function here, 2 sine 2x, is the derivative of that function. So this function on the right, g of x, is the antiderivative, or is an antiderivative of f of x. By the way, this 4 could have been replaced by 40. You will get the same answer. It will be an antiderivative. Moving to the next capital G and deriving, you will get 2x minus 3, which is here. So this G is the antiderivative, or is an antiderivative of that one. Moving to the next one, G prime, this is u times v, so it's u prime v plus v prime u, which is cosine x minus x sine x, which is here on the left, the fourth function. Consequently, this capital G of x is nothing but the antiderivative of this one. Finally, x squared minus 6, if you derive it, you will get 2x. So this function is an antiderivative of that function. Again, notice here, x squared minus 6. What if it's x squared minus 100? You will get 2x. So actually 2x, how many antiderivatives it has? It has infinity of antiderivatives. They have all to be starting with x squared, but the constant here can be any constant. So we say x squared minus 6 is just an antiderivative of that one. Consider the polynomial function small f defined on R by f of x equals 3x squared plus 4x minus 5. Calculate a, b, and c such that the function capital F defined by f of x equals ax cubed plus bx squared plus cx is an antiderivative of f. If this function is an antiderivative of f of x, then its derivative must be the lowercase f of x. So let me derive the capital F of x. I will get 3ax squared plus 2bx plus c. For sure here, this function must be equal to the small f of x, to the lowercase f of x. comparing the coefficients. So 3a must be 3, 2b must be 4, and c must be minus 5. Consequently, a must be 1, b must be 2, and c must be minus 5. Consider the function lowercase f defined by 2x. Let capital F, capital G, and capital R be three functions defined on R as x squared minus 3, and x squared plus 1. Calculate the derivative of each of the following functions: f of x, g of x, r of x, capital. So f prime of x is 2x. G prime of x is simply 2x because the derivative of minus 3 is 0. And the derivative of r is r prime of x equals 2x. What can you deduce? We can deduce that these three different functions are all considered antiderivatives of the same function 2x. But what about them? They differ only by a constant. The expression in x is the same in all of them, but they differ by a constant. So if you find g of x minus f of x, you will get a constant because the x squared will cancel out. So we deduce that the three functions are antiderivatives for the same function lowercase f because the derivatives of these three functions are equal. Consequently, how many antiderivatives does the function lowercase f of x equals to x have? Here are three of them, but actually you can replace any constant here by any other constant. Consequently, you have infinity of antiderivatives for any given function. We conclude that every function has an infinite number of antiderivatives that differ by a constant. If capital F is an antiderivative of the function lowercase f, then any other function which is the same as capital F of x plus any other constant is also an antiderivative of the same function. So if the function f defined on the interval is an antiderivative of the small function f, then the set of all antiderivatives of the function f is defined by f of x plus c. So actually, to find the set of all antiderivatives of a given function, it's enough to find or to think of one of them, and then simply you add a constant. This is denoted by integral of f of x d of x. So the symbol integral, this is a new symbol that you need to know. So this symbol, integral sign, is a symbol that represents the set of all antiderivatives of a certain function. So when I write integral of f of x dx, I'm telling you to find the set of all antiderivatives and not just one. And you do it by finding one and adding a constant. Examples. What is the integral of 5 dx? This symbol means, first, the integral sign means the set of all antiderivatives. 5 inside is the function or the integrand, the function which is inside the integral, the function that you're trying to find its antiderivative. Dx is just a symbol to tell you about the variable in this context. As you know, when you write a function f, you write f of x. Sometimes you write f of t, so you know that the variable is t and not x. So on the integral, since we are dealing with functions, I have to tell you the name of the variable. Is it t? Is it x? Is it u? Since I'm writing dx at the end of the integral, so I'm telling you that the variable that you are working with in this context is x. So each integral must end up with a d whatever. So give me a function or give me the set of all functions that are antiderivatives of 5. That's simply 5x plus c, because the derivative of 5x is 5 plus c. You can replace c with any arbitrary real constant. What is the integral of 2x dx? I'm asking you to find the set of all antiderivatives of 2x, where x is the variable. Some students may think of x squared, which is correct. But what about x squared plus 1? It's also correct. Can we list all these? No. We simply write x squared plus c. You must write plus c. Otherwise, you are giving me just one possible answer, but I'm asking you to give me the set of all possible answers because I have used the sign of the symbol integral. Integral of 3x squared. For sure, here you're trying to find your answer by thinking, by trial and error. Next, we will learn how to find the answers to these systematically. But now it's okay if you think about it mentally because these are easy functions. So you can think about it, but you can think backwards. Can you find a function whose derivative is a 3x squared? I think it's easy. It's x cubed. So the final answer will be x cubed plus 3. If you cannot find the answer till now, it's okay. Because next, in the next slides, you will learn how to find the answers systematically. So we need to know some basic rule. To find the integral of any function which is in the form x to the n, it could be x squared, it could be x cubed, it could be x to the 10.7. So simply to find a function whose derivative is x to the n, it must be x to the n plus 1 over n plus 1 plus c. To make sure that this formula is correct, you have to derive this answer and you will get x to the n. Examples. What is the integral of x squared? This function here, the integrand, the expression inside the integral is in the form x to the n. So apply the basic rule. Rule 1. You add 1 to the exponent and you divide by this. This is the answer, plus c. What is the integral of x to the 10.7? Give me a function whose derivative is x to the 10.7. Since this function is in the form x to the n, then the answer should be x to the n plus 1 over n plus 1 plus c. Always to make sure that your answer is correct. You can't derive your answer. You must get the quantity inside. What is the integral of 1 over cubic root of x? It's very important when you're working with integrals or finding the antiderivatives to make sure that the form of the function is matching the rule. I'm talking here about basic rule 1 where the function is in the form x to the n. For sure, not all functions are in the form x to the n. But some functions are clearly in the form x to the n, like x squared, like x to the 10.7. Is the function 1 over cubic root of x, is it in the form x to the n? Actually, yes, but it's not clear. So the first step here is to work on the integrand. You keep the integral sign because now I'm not integrating. Now what I'm doing is simplifying or rewriting the integrand in an appropriate way so that it's ready to be integrated. So since now the function is well written, it's written as in the form x to the n, where n is any real number except minus 1. So I can apply the rule by adding 1 to the exponent and dividing by this, because minus 1/3 plus 1 will be 2/3, and you divide by 2 over 3. You can simplify your answer to be written as 3 over 2 cubic root x squared plus c. It's more elegant to write the answer like this. Rule 2. If the function or the integrand is k, where k is a constant, not an expression depending on the variable. If k is a constant times x to the n, you can forget about this k. You can keep it outside the integral. Then you do the integral of x to the n. Examples. What is the integral of 4 times x to the 4? Since this 4 is a constant multiplied by x to the n, you can get it outside and you integrate x to the 4, which is x to the 5 over 5. So the final answer is 4x5 over 5 plus c. What about half x cubed, x to the minus 3 dx? Again, you can get this half outside the integral. Now inside the integral, you have x to the n. You add 1 to the negative 3, you will get negative 2. and you divide by this -2, simplifying, you will get -1/4x to the -2, which is -1/4x squared plus c. So in general, if you have k times any function, you can get this k outside, then you integrate the function itself. Rule 3. What about the integral of f of x plus g of x or minus g of x? So actually, if you have a sum or difference inside the integral, you can integrate each by splitting the integral. So the integral of the sum is nothing but the sum of the integrals. Similarly for the difference. Example, you have integral, but be careful here, the variable is t. It's exactly the same. It's only x replaced by t. If you're writing dx here, then I will look at these as if they are constants. But here, no, the variable is t, so t squared is a variable, t cubed is variable, and minus 2t to the 4 is also a variable. Here you have a sum or a difference or whatever, so you can split the integral into 3 different integrals, and you can get this 2 outside. Now you are integrating each one of them. It will be t cubed of 3, t4/4, t5/5. For sure, you write only one constant for all the integrals. Rule 4. What about the integral of the function cosine x? Actually, it's sine x because the derivative of sine x is cosine. Now, what about the integral of sine x? It's minus cosine x. Why? Because the derivative of cosine is minus sine. So you need to multiply by minus so that when you derive, you will get sine x. Be careful here not to mix these with the derivatives. Actually, they are the opposite. Example, find the integral of radical 3 sine x plus 2 cosine x. Since you have a sum or a difference, you can split into 2 integrals and you can get the constants outside. Now the integral of sine is minus cosine and the integral of cosine is sine. That's a rule that you need to know by heart. Be careful here that the integral of the product is not the product of the integrals. And the integral of the quotient is not the quotient of the integrals. You don't have the right to do so. You will ask me, what if I have a product inside? You have to get rid of the product form, perhaps by expanding, then integrating. So whenever you have an integral which is in the product form or in the quotient form, you need to work on the expression. Particular cases, what about the integral of k dx? If k is any constant, then the answer is kx, because the derivative of kx is k. Examples, what is the integral of 3? It's 3x plus c. What's the integral of 2x squared minus 6? For sure, you can split the integral, but you don't need each time to write 2 integrals. Directly, you integrate each part alone. No need to write 2 integrals. The integral of 2x squared is 2x cubed over 3, and the integral of 6, which is a constant, is 6x plus c. What is the integral of x? That's a very special function. As x actually is x to the 1. So it will be x to the 2 over 2 plus c. What is the integral of 3x? X to the 1, you add 1, or the integral of x is x squared over 2. What's the integral of x cubed minus 2 plus x? Now, you can split into 3 integrals, but you don't need to write 3 integrals and waste your time. All what you need to know that since you have addition and subtraction, you can integrate each term alone. So x cubed is x4 over 4. Minus 2 is minus 2x. X alone is x squared over 2. In all cases, whenever you want to check the validity of your answer, you can derive your answer. You must get the quantity inside. Otherwise, something went wrong with you. What about the integral of 1 over x squared? That's a standard function, by the way. You can know this by heart. It's minus 1 over x, and you can prove it. How? First, 1 over x squared can be written as x to the minus 2. So you get this x squared up, where it's x to the minus 2. You add 1, it will be x minus 1 over minus 1. and the answer will be minus 1 over x. But from now on, you can know that by heart. Whenever you have integral of 1 over x squared, you can write it directly minus 1 over x. So what's the integral of this one? For sure, here the integral is x minus 2 over x all to the power 2. It's not matching rule 1 or rule 2 or rule 3. This is u to the n. What is the integral of u to the n? We don't know. So all what we need to do here is first to split this integral and to expand as x squared, like a minus b all squared. So it's a squared minus 2ab plus b squared, and you are splitting into 3 integrals. Now you integrate each. X cubed over 3, 4 is 4x. The integral of 1 over x squared is nothing but minus 1 over x directly. What's the integral of radical x? Radical x is also a standard function. You may know that by heart, but you don't need to memorize this. But in all cases, you have the right. But in all cases, if you want to do it yourself, radical x is nothing but x to the half. So now it's written in the form x to the n. So you add 1 to the exponent, it will be 3 over 2, and you divide by 3 over 2. Simplifying this, it will be 2 over 3 x radical x plus c. Actually, if you have integral of radical x, you have the right to give the answer directly. Examples, what is the integral of radical x plus a 3 all squared? First of all, you don't know a rule that gives you the answer directly to the integral, which is in the form integral of u to the n. So you have to get rid of this form. So before integrating, I need to work on the integrand by rewriting this. How? I expand. A plus b squared is a squared plus 2ab plus b squared. Now splitting into 3 integrals, integral of x is x squared over 2. Radical x, you can write it directly, or you make it x to the half, then you add whatever. 9 is 9x plus c. What about this integral? 1 over radical x dx. Actually, you don't need to know this by heart. All what you need to do is first write the integrand in an appropriate way. Actually, radical x is x to the half. So if you take it up, it will be x to the minus half. Now, it's matching the form x to the n. So you add 1, you will get x to the half, and you divide by half, and that's 2 radical x plus c. You don't need to memorize this. You can do it like this. Thank you for this session.